In our last video, we defined what quality is and gave an overview of quality management. We also highlighted some of the historical evolution of quality and discussed some of the awards and the certifications that are out there for quality management. We also talked about some of the costs of quality, whether that's improvement to profitability by having good quality, or some of the losses that you can take when you have poor quality. So in this video, we're going to talk about total quality management. And total quality management is the management of the entire organization so that it excels in all aspects of products and services that are important to the customer. So we're going to talk about 7 different concepts that help to make an effective total quality management program. So I'll call it TQM, total quality management. They're exactly the same. And what we're going to learn about today is continuous improvement, Six Sigma, employee empowerment, benchmarking, JustinTime, TQM concepts, and knowledge of TQM tools. So those are the 7 concepts for total quality management. Now, we are not going to learn about the TQM concepts. It's in the book, and you can read more about it if you would like. But I am not going to discuss it today, and I'm also not going to test you on it. Frankly, it takes too long and it's very complicated. But what the TQM concepts cover is engineering and experimental design processes, looking at product variation and quality robustness and the loss of function. So that is the TQM concepts. It is covered in the textbook. You can read it if you'd like. But again, I will not be testing you on TQM concepts. So we're going to go over the other 6 total quality management concepts going forward. So the very first total quality management concept is continuous improvement. This represents the continual improvement of processes. And it's actually hard for me. When I say continuous improvement, I have to be intentional to say continuous improvement and not continuous process improvement, because that's what I've historically always called it. So that just goes to show how ingrained continuous improvement is with looking at processes. It involves all the operations and work centers surrounding suppliers and customers, and you focus on people, equipment, materials, and procedures. So you're looking at everything that has a process surrounding it and how you can improve those operations. For continuous improvement, you can use Schohart's PDCA model, Plan, Do, Check, Act, or you can use Deming's Plan, Do, Study, Act. They're both pretty much the same thing. With the PDCA, you're looking at plan, so you're identifying the problem and making a plan. Then you do, so you test that plan. Checking is check the plan, make sure that it's working. Did your changes to that process yield a good result? And then the last one is act, so you implement the plan, you document it, and then many times you will start over again. That's why you see continuous process improvement is almost always noted as a wheel, because you can make some improvements, look at the process again, make more improvements, look at the process again, and make more improvements. It is continuous process improvement. There is not an end goal. So PDCA, PDSA, both of them are literally the same thing, but they are heavily ingrained into the continuous process improvement concept. Next is Six Sigma. Six Sigma has 2 meanings. One of them is statistical, and one of them is a program. So a lot of times you'll hear people say, oh, I've got a Lean Six Sigma program at my employer, or I've got a Lean Six Sigma green belt, which is what I have. So a program is designed to reduce defects, lower costs, and improve customer satisfaction. It's when it's a highly structured approach to process improvement by using different lean tools, many which we'll go over in Chapter 16, and Six Sigma programs. Again, we'll go over a lot of that in Chapter 16 as well. But it is a structured approach to continuous process improvement. So a lot of people say they have a Six Sigma program, and what they mean is a program to look at lean process improvement, trying to improve quality to get it closer to that Six Sigma level. Many organizations will have no intention of actually becoming Six Sigma quality, but they do want to improve their quality to get to an acceptable limit for themselves and for their customers. Six Sigma was originally developed by Motorola. It was adopted and enhanced by Honeywell and GE, so you hear a lot about Six Sigma at Motorola, Honeywell, and GE because they were early adopters in that, and they continue to have that culture of Six Sigma and continuous process improvement even today. So there's two meanings. The first one is statistical. The second one is a program. I've already discussed what a Six Sigma program would look like. So now let's talk about the statistical definition of Six Sigma. So the statistical definition is a process that is 99.9997% capable, having no more than 3.4 defects per million opportunities. So DPMO, defects per million opportunities. So if you make 1,000,000 of these red pens, to be Six Sigma quality, you'd only have a defect on 3.4 of them, or essentially in this case, because it's a product, 3. So 3 defects out of 1,000,000 opportunities. So that's Six Sigma quality. If you look at the bottom right of your screen, you can see that Six Sigma quality is only 3.4 defects per million. Now, you can be 5 Sigma, you can be 4 Sigma quality, you can be 3 Sigma quality. So 3 Sigma quality is 2,700 defects per million. So lots of organizations, again, when they say they have a Six Sigma program to improve quality, doesn't mean they have 3.4 defects out of every million. They're just on that journey of continuous process improvement to try and improve their quality. And maybe they get from 1 Sigma to 2 Sigma, then to 3 Sigma, and they determine that 3 Sigma is good enough quality for them and for their customers, and maybe they stop there. But so statistically, Six Sigma means 3.4 defects per million opportunities. A defect can also be called a nonconformance, and a unit of work is the output of a process or an individual process step. So you can make a process Six Sigma, or you can make the output of a process Six Sigma. You can work on different steps in that process, or the overall process, or it can be measured as the amount of defects per million opportunities within a finished good product as well. So Six Sigma, 2 meanings, 1 statistical and 1 is a program. So let's calculate out the DPMO, the defective parts per million opportunities. In service firms, you can call it the errors per million opportunities, or an EPMO. But either way, the calculation is the same. So you've got your number of defects over the number of opportunities for error per unit multiplied by the number of units. So if you're making a pen or you're processing a loan application, that is 1 opportunity for error per unit. If you're building things in batches, or you're doing 2 at a time or 3 at a time, then you would have your per unit would be different. But the majority of the time when you do this calculation, your number of opportunities per error of unit will be 1. But you need to be very careful if you've got a different unit of measure to make sure that that is noted in the calculation. So let's do an example together. Customers of a mortgage bank expect to have their mortgage applications processed within 10 days of filing. Suppose all defects are counted, which are loans in a monthly sample taking more than 10 days to process, and it's determined that there's 150 loans in the 1,000 applications processed last month that don't meet this customer requirement. So what's the errors per million opportunities for this process? So first of all, your number of defects. This bank wants to have loans processed within 10 days. If they don't, if it takes them 11 days, or if it takes them 12 days, or if it takes them 25 days, whatever that number may be, if it takes them more than 10 days, they consider that a defect. Because there's only 1 loan per unit of measure, so essentially 1 loan per applicant, that means that the number of opportunities per error per unit is 1. Your number of units is however many loans applications they see every month. So in this case, it's 1,000 applications per month. So to get the errors per million opportunities, you simply take 150 divided by 1 multiplied 1,000 times 1,000,000. So for this bank, they are having 150,000 loan errors out of every million. Okay, 150,000 loan errors out of every million. So if you go back 2 slides, and I showed you that, that distribution of 6 sigma and 3 sigma, Six Sigma was 3.4 errors out of every million. Three Sigma was 2,700 errors per million. This bank has 150,000 loan errors, or they have errors, 150,000 errors per million. That's terrible. Okay, that's horrible. Now, the question would be, what do they want to do about it? Do they really want to get to 2 Sigma or 3 Sigma quality? Because if so, then they would have to make some improvements to their loan application processing process. They would have to see what's taking us so long. Why is it taking us more than 10 days? And so they would have to make those improvements to get their defect rate down to not having 150,000 errors out of every million. So that would be up for the bank to decide what they want their quality to be. But right now, it's pretty bad. It's 150,000 for every million. Okay, so in Six Sigma, you cannot have a Six Sigma program if you don't understand the acronym of DMAIC. So the DMAIC methodology is define, measure, analyze, improve, and control. It pretty much follows along with everything that we've talked about for continuous process improvement, plan, do, check, act, plan, do, study, act. You're going to see a reoccurring theme with everything that has to do with quality improvement and lean process improvement, where you're looking at a few-step process, focusing on what the customer wants and how you can improve those processes. DMAIC is no different. Your first step is define, identify what the customer wants and their priorities. Next, you measure. That's determining how to measure the process and how you're going to see if you're performing. Identify key internal processes that influence your critical to quality characteristics and measure your current defects. Next is analyze. You're going to determine the likely causes for all those defects and understand why the defects are generated in the first place. And maybe what are some of the variables that are causing the defects as well. So you're going to analyze your data. Next is improve. And this is identify the means to remove the causes of defects and variations and modify your process within an acceptable tolerance limit. And then last is control. So control is determine how to maintain improvements, putting tools and processes in place to ensure that the variables in the output remain stable within that acceptable range under your modified process. And why the control phase is so important is, let's say we go back to that last example on the last page, and all the loan processors of this bank know that they're now being monitored. So it's possible that if they aren't working very quickly, that they just start to speed up because they know they're being measured. So they start to improve the amount of defects that they have per month, and they start to have a lot more loans that are processed within that 10 days. Well, that's not a process improvement. And as soon as those employees know that you're not looking over their shoulder, they will probably go back to their old ways. So you have to look for non-value added steps or redundant steps in that process and find ways to improve the process. Maybe people are part of the problem, but generally, when you have that many defects, it's more of a process problem versus a people problem. So you need to put control measures in place to make sure that it doesn't go back to where it was before you started measuring performance. So DMAIC methodology and Six Sigma go hand in hand. Every Six Sigma program will follow the DMAIC methodology in one way or another. Okay, the next concept within total quality management is employee empowerment. And this is getting employees involved in the product and process improvements. It might seem obvious that you should empower your employees, but again, not all organizations act like this. Some organizations do not ask people who are on the production floor or who are out in the field, hey, how can we improve quality? What would help you do your job better? Hey, we've noticed we're making mistakes in this area. Can you explain what we could do to help you in that area so that there aren't as many defects in the future? And you don't place blame on those employees, but you genuinely partner with them and empower them and give them an open forum where they can speak so that they will want to help improve quality for the organization. So if you remember Deming in the last lecture recording, I stated that Deming back in the 40s and 50s said that 85% of the quality problems are due to processes and material and not your people. So even if a person many times is making a mistake, it's probably because the process is not good enough to make sure that they don't do errors. Okay, you want to poka-yoke your processes. You want to improve those processes so that people cannot make mistakes. Poka-yoke, by the way, I just threw that phrase out. Poka-yoke means error-proofing or fool-proofing. It makes things to where you cannot make an error. An example of that would be, I went to a manufacturing facility in Shanghai, and they used lots of different screws on a printed circuit board assembly. And for where one size screw went through one hole, it was painted red around the hole, and then the screw was painted red. Next to it was a blue hole, and the screw was painted blue. Next to it was a green hole, and I'm not making this up. So there was various holes all over this printed circuit board assembly, colored blue, green, and red. And then they purchased blue, green, and red screws. So the employees could not make the mistake, or it made it far harder for them to make the mistake. When you're screwing in a blue screw, it better be going into a blue hole. When you're screwing in a red screw, it better go into a red hole. That is poka-yoking a process. Okay, so if you ask your employees in that instance, hey, why do you keep putting the wrong screw into the wrong hole? They would say, well, all these screws are so similar. You know, sometimes I get confused when I'm sitting here working for 8 hours a day, which screw goes in the right hole. So if you empower your employees and you give them an open forum for feedback, many times the people who are on the front line know areas where you can have quality improvements just by asking them. Okay, the next total quality management concept is benchmarking. Benchmarking is selecting the best practices to use as a standard for performance. So the process of benchmarking is essentially determine what you want to benchmark, form a team of benchmarkers, identify the benchmarking partners. Generally, that would be an organization that is not your competitor. Someone, many times in a different industry, where if you want to improve your quality processes or your inventory management practices or supply chain, you go and you benchmark a company who is really good at that, but when they share all their secrets with you, you won't be competing, okay? So you can benchmark processes to improve your processes and to improve your quality. In addition to benchmarking processes, you can also work with other industries to benchmark products as well. So I saw an article the other day that I thought was pretty clever. I've posted it on Canvas for you. And it showed a sushi restaurant and how they had a carousel, which they had gotten the idea from the airports, how the airports have luggage moving around. Well, this sushi restaurant, had sushi moving around on a carousel of their own. You've probably seen more of this recently, where drive-thrus, or for fast food restaurants, they've got 2 lanes in the drive-thru. Well, they got that idea to improve their process and improve their throughput through Formula One and their pit stops. So that's benchmarking products, and those are things that you can get as a best practice from outside of your industry. Okay, the next total quality management concept is just-in-time. Again, just-in-time we will talk about more in Chapter 16 on Lean and Six Sigma. But just-in-time is a philosophy of continually improving and enforced problem solving. So that's the key phrase with JIT. Everyone just thinks of JIT as let's reduce inventory. And that's a big piece of it. But when you reduce inventory, you actually create and uncover problems. So by reducing your inventory, you are literally enforcing problems on your system and on your process. So when you implement a JIT type system, these are designed to produce or deliver goods right when they're needed, and you're going to start having issues, okay? JIT will cut the cost of quality, it improves quality, and better quality means less inventory and better, easier to employ just-in-time systems. So let me give you an example of why reducing inventory can help to improve your quality. So this slide you'll see again in another lecture recording on Chapter 16, but inventory hides problems. Okay, think about that for a second. If you're a manufacturing firm and you've got thousands of SKUs on hand, inventory hides problems. And problems in that kind of setting mean maybe you've got some quality problems with your supplier, but when you get them an incoming inspection, you send them back, you get more inventory, voila, you never had a shortage on the manufacturing floor because you had a bundle of inventory. Maybe your supplier continually delivers late. So they're supposed to have products here in 3 weeks, but they're always here in 5, but you never know because you've always got excess inventory. Maybe you've got high levels of scrap, or your setup process is really slow. Maybe it's supposed to take 3 hours to set up a process, but instead it takes you 8. It takes you a full day to do a setup process, but you never know because you have an inventory as buffer. So when you proactively and intentionally start to reduce your inventory, you actually start to make your own problems, okay? So these little rocks that you see, okay, these little bumps under the river here, these are problems. So as you go from A to B and you reduce your inventory, you start to uncover problems. Those problems are exposed. And that might seem like a bad thing, but we are talking about a total quality management process improvement, and reducing your inventory helps to expose quality problems that you need to address. So by reducing your inventory, you expose problems. You can then go and address those problems. So now in step B here, you've now exposed the problems with your setup time. You've exposed problems, quality problems. You've exposed some late deliveries. So then you go address those issues, and you can reduce your inventory even further, and you won't have any problems. Okay, so that's why you're going to have lower inventory, lower costs, and higher quality by implementing just-in-time concepts. Okay, so that was number 5 of our total quality management concepts. We are going to skip number 6, which is the Taguchi concepts, and the last concept for total quality management is the 7 quality control tools. And we will talk about these 7 quality control tools, which are tools for generating ideas, tools for organizing data, tools for identifying problems. So those 7 different quality control tools we will talk about in our next video. Okay, so I'm going to have a separate video just for these 7 quality control tools. It's just a sheer coincidence that there's 7 principles or concepts of total quality management, and then there's also 7 quality control tools. It's just a coincidence there's both 7 of each, but the 7 quality control tools is our next lecture recording. So let's conclude talking about total quality management. And in the very first video we saw in this course, in chapter 1, I talked about the differences between goods and services, and how services are harder to gauge, they're harder to measure, especially for productivity, but also for quality. So when we talk about service quality, it's more difficult to measure than it is for the quality of goods. And that's because customers have a perception of quality. Like we talked about in the last video, our perception of quality matters, and that is a varying scale. We all have different expectations of what good quality is and what poor quality is. So we have different expectations, and our perception of how that product or service met our expectations varies from person to person. It's also important to understand that as an operations manager in a service firm, that there is a tangible and an intangible piece of our quality program or our service that we provide to our customers. So let me give you an example of the difference between something that's tangible and intangible. If I have someone come to my house and clean my carpet, and they do a wonderful job cleaning the carpet, that's the tangible piece of the service. Okay, they've cleaned my carpets, they've done an amazing job, that's the tangible piece. But what if the service technician that arrived at my house was late, super rude about it, and they broke my lamp in the process of cleaning the carpet? That's the intangible component of a service. So you have to keep in mind that it's important that the tangible piece of the service and the intangible piece of the service are extremely important to customers' perception of quality. Okay? Both matter. The output of the tangible piece and the output of the intangible pieces, essentially your customer service. Customer service matters a lot for people's perception of quality. Okay, so we are done highlighting the 7 concepts of total quality management. In our next video, we're going to discuss the 7 quality control tools.